Hello, this is Junhan. So what I want to talk about today is actually microscope and telescope because in your chapter light, I suppose this is one of the things that people ask about, right? So, but here's the thing, this video, right, mainly it will be talking about the feature, as in like basic things like what are the difference between them and then how you choose between lenses and everything. Regarding the drawing, right, you can refer to the video. I will put the link after the video, after this video, so you can refer that. So basically there's like part 1, part 2. So this one is part 1. And then after that, you can go for the drawing video and then there will be part 2. So basically you learn everything. Because for telescope, microscope, right, besides knowing how to draw, sometimes you need to know the feature as well. As in like which power has to be bigger, which lens am I supposed to choose a higher focal length or even like a higher power? And then the other one is how do you calculate everything? Okay, so for lens, we all know there is calculations for your lenses. But the thing is, for telescope and microscope, the calculation formula is a bit different. You cannot use what you use usually for your light. For example, let's say they ask you to calculate magnifications. Usually when we do magnifications, right, we will just do like what? Height of image over object, distance of image over object. But then, right, for telescope and microscope, to calculate magnifications, you have your own formula one. So that's why I want to go through this now. Okay, come, let me show you this. Okay, so now this one, right, I'll go through one by one. We talk about telescope first, and then we go for microscope. Both of them now, right? Now, here's the thing. Basically, right, telescope and microscope, they are both considered as the compound lenses. Now, the idea of compound lenses means you got two lenses. But anyhow, right, you bear this in mind, right? Telescope and microscope, right, both of them, we only uses one type of lens, which is what? Over here, convex lens. We don't do concave one. Only we will basically be using convex lens. Now, the reason actually quite simple. If they ever ask you, why do we use convex instead of concave? That is because convex lens, you can do something concave cannot, which is be able to produce a real image. Because you see, you got two lenses. So your image for the first lens, right, it has to go to the second lens one. Yes, it has to be projected to second lens. That's why, right, the image that produced by the lens, it needs to be a real image. Especially your first image, your first lens, they need to be able to produce real image. And the fact is that concave lens, right, they don't do this because concave lens, you only have like one type of image. No matter what, they always give you virtual. So that's why, right, for convex, we can have virtual image, we can have real image. So this is the reason why do we choose convex. So if they ever ask you, sometimes there's essay asking you, should I choose convex or should I choose concave for my telescope, for my microscope? Then you choose convex. And the reason very simple. You just tell them because it produces a real image. Okay. Now, first of all, right, you see, for telescope and microscope, right, both of them, you will have two lenses. Okay, you have two pieces of lens here. And as I said, they will be convex lens anyway. Okay, so one piece of convex lens, and then you have another piece of convex lens over here. Well, you got two lenses, right? So definitely there will be two different names. One of them will be known as the objective lens, and then the other will be eyepiece lens. Now, there's no fixed one saying that, must this be your eyepiece or must this one be your eyepiece? Not necessarily. It's not fixed one. Okay, it depends on where your eyeball is, like where you put your eyeball. For example, if you put your eyeball here, let's say the diagram the question gave you, they put an eyeball here, as in this is where you see. So this one is the one that your eye looking at. So that's why we call this as the eyepiece lens. Okay, so if you decided to put your eyeball here, then this will be eyepiece. Exactly, it doesn't matter one, whichever you can. Now, and then the other side, of course, it will be known as the objective lens. And you know why is it called objective lens? Because objective lens. Okay, basically, as you can see, objective lens. All right, the lens that is facing the object, that's called objective lens. And then the lens that you're looking at, your eye staring at, that will be eyepiece and then objective. Understand? Okay. Now, there's two things you must know. There's only two things you need to know, right? Now, for telescope, for microscope, basically, right, the thing you need to know is what? Number one, the lens power. Which one has to be bigger? Which one has to be smaller? They don't tell one. They would. This is the question that they will ask you. Exactly. Like for example, they will tell you that, I have two pieces of lens. Okay, one of the lens, say for example, one of the lens, right, the power is 10 diopter, and then the other one, right, is actually 50 diopter, and that's it. They ask you to choose yourself. So you need to know which one should you choose, the bigger one, and which one should you choose the smaller one. Okay. Now, for telescope, microscope, the balik one, simple as this, you just reverse them. Okay, so let's say for For telescope, right? Simple. That is the mind. Telescope, right? Your power. Now we are doing telescope. Now we are dealing with telescope. Okay. For telescope, right? Your power of eyepiece, it will be larger than objective. Whereas your microscope, right? Your objective power will be larger than eyepiece. So as you can see, they are reversed. Okay. Now you can literally use the same lens. You know, let's say for example, you got two lenses here. You got 10 diopter. You got 50 diopter. So two of these, right, it can be used to build a telescope and also a microscope. Depends on whichever you choose to be your objective, whichever you choose to be your eyepiece. Let's say, for example, we deal with telescope. So what happened? The power of eyepiece, it has to be larger than objective. Okay, so that means, right, out of these two, I will choose the 50 diopter one as my eyepiece, and then the 10 one as my objective. The number is all random. The question will be provided. The question they will provide it to you. So must I memorize the 10 and 50? Not necessarily. Okay, so that's the first thing. But there is one thing I need you to understand as well. Here, right, I'm telling you the power of your eyepiece has to be larger than objective. But you need to understand one thing as well. Focal length. How do you calculate focal length? You basically, for focal length, right, it's actually like this. Power equals to 1 over f, right? So f equals to 1 over power. So that means, right, if your power is bigger, actually your focal length becomes shorter one. So that's why, right, now for power of eyepiece larger than objective, right, then here's the thing. When we talk about eyepiece focal length, it will be reversed. It will become shorter than your objective. Okay, now that's the first thing you want to know, the structure. The eyepiece power for telescope is bigger. And then for microscope, right, the balik. For microscope, right, the eyepiece power will be smaller compared to the objective. They are reversed. They are reversed. Okay, and then remember, sometimes they will trick you this way. They don't give you the power. They will tell you the focal length straight away. For example, they say, I have two lenses. The focal length of that one of them is 6 cm. And then the focal length of the other one is 2 cm. So now, right, you have to reverse the logic. As I say, telescope, eyepiece, power bigger than objective, all right? But the thing is what? Focal length for eyepiece is actually shorter than objective one. So that means, right, whenever you're choosing this, you need to choose you have to choose a shorter one as your objective, your shorter one as your eyepiece, and the longer one as your objective. Okay, so you have to see, depends on what's given. Sometimes they give you the power, sometimes they give you the focal length. So you cannot say, oh, can I just memorize power? Can I just ignore about the focal length? No, because they will be both. Sometimes they give you power, sometimes they give focal length. Okay, so that's the first thing you want to know for telescope, right? Your eyepiece power bigger than objective, right? Now, the second thing you need to know is what? The distance between the two lenses. All right, over here, they will always put like here, from the distance of objective all the way to eyepiece, as in the distance here. Now, we normally put a symbol. We will put an L there. The L stands for distance between the two lenses. Again, telescope, microscope will be different. Okay, for telescope, very simple. Telescope, right, is basically equals to FO plus FE. Because sometimes, right, there are questions where they don't ask you draw. They only ask you calculate. Let's say, for example, I can give you the power of objective and then power of eyepiece and ask you calculate the distance of them. How you do that? Now, for example, okay, let's say the question gave you power of objective. The power is, doesn't matter which one. I give you two lenses, right? One is 10 diopter, the other is 50 diopter, like this. And then you need to calculate distance for me. So how we do that? Simple. Now, it doesn't matter which one is which now, because why? It's FO plus FE. Both of them, you're going to use it anyway. But of course, the best is if you know which one is which I told you again. For telescope, PE bigger than PO. So FE has to be shorter than FO. So that means, right, what do? I will choose this one as my PE, and then this one 10 as my PO. But we are trying to calculate focal length, not power. So power equals to 1 over F. And then your diopter is 10 equals to 1 over F. F equals to how much? It's going to be 1 over 10, which is equals to 0.1. Now, this is one thing very important because everybody make mistake. Most of the time, right, your focal length will be given to you in cm. But whenever you try to calculate power, or whenever they gave you the power, you want to convert back to focal length, right? You need to understand this one, it's in terms of 10 diopter. It means it will be in SI unit. So whatever result you're getting, that is also SI unit. Means actually this one, right, it's actually meter, 0.1 meter. So when you convert, right, it has to be 10 cm. You getting what I mean? Now, biggest mistake of all time is always careless one. Always remember, whatever you found, it's only meter. You need to find out the cm times 100. Simple. Okay. Now, once you got this, the other one, right? Simple. I calculate for the 10 already, right? I will do the same thing anyway. This one is PO, so this one is FO, right? Power of objective smaller, ma. So I will do the same thing anyway to calculate for my PE. Power of eyepiece equals to 1 over F anyway. Diopter 50 equals to 1 over F. Again, focal length equals to FE. It's 1 over 50, which I think you get 0.02. And convert back to cm is 2 cm. So ultimately, right, when you try to calculate this, your distance between two lenses will be 10 cm plus 2 cm. Your answer is 12 cm. Getting it? No need to convert back to meter anymore. You can keep it this way. All right. So these are the things. There are two features now. Number one, you need to know which one power is bigger. Number two, the distance between the lens. Okay, which is called L. Sometimes you see they say L at normal adjustment, means the normal setting lah. All right. L equals to FO plus FE. Okay, focal length of objective plus eyepiece. How we found focal length? 1 over F, 1 over F. Okay, now that is for telescope. Now we move on to next one. Next one, right? Imagine now I take all these away. All these gone. All right. We take all these away. All right. Now we go to microscope. For microscope, very simple. Once you understand telescope, right? Microscope is not an issue anymore because why? Microscope, simple. The idea will reverse. Just now for telescope, right? PE larger than PO. Then what happened for microscope now? Simple. Now, right, your power of objective, it will be larger than eyepiece. That means, right, same value. Now I would choose the 50. Now I will choose the 50 as my objective. Then the 10 as my eyepiece. Pretty much the same thing anyway, just reverse. But then one more thing. What about distance between lens? Now microscope, very simple. Microscope, they don't actually calculate one because why? It's just arranged. Whenever they calculate this, right, this will be more than FO plus FE. Exactly. Means what? For example, if FO plus FE equals to 12 cm, then for the distance, right, you could choose any number more than 12. 13 also can, 14 also can, 15 also can, 20 also can. All right. So they don't ask you to calculate this because it's just a more than. There's no fixed answer. You don't have a unique answer like must be 12, must be 20. No. All right. So normally, right, if you ask me now, calculation wise, right, the thing that normally ask more often is telescope because there can be more calculation involved. Okay. So for microscope, simple. Number one, the power of objective larger than eyepiece. Number two, the distance between them. The distance between them, it's more than FO plus FE. It's just more than. There's no calculation needed. Anything more than the value you sum together, it will be the answer. Okay. So now two things already. I talk about the power. Which one has to be power objective? Which one has to be eyepiece? The other one, right? I also tells you the distance between the lens. Telescope is equal to sum of them. Microscope is more than the sum of them. Now, last one is calculations about magnifications. All right. Now the diagram I take away, no point really. So after this, right, there will be one thing they like to ask as well, which is this. They ask you to calculate the magnifications. Okay. Now for telescope, the thing is what? We use telescope to look at object that is very, very far away, distant object that is very far away. We tend to assume them to be infinity light rays. That means you don't really have an object starting, and your image form will not you will not have anything as well. Basically, just two light rays that's parallel. So that's why, right, there's no image form for you for telescope. So what do you do, right? Simple. You will take FO over FE. That's it. Okay, the focal length of objective divided by eyepiece. That would be the magnification for telescope. Exactly. Now, for microscope, right? Microscope, you actually do have image form because microscope, we use it to look at things that's very, very small. You used to enlarge a very tiny object, like your cell wall, your onion cell wall, stuff like that, right? So for this one, right, we can actually use formula to calculate them. How we do that now? Now there's actually two formulas. For microscope, right, we have two formulas. Number one is MO times ME. You take the magnification of objective, multiply by the magnification of eyepiece. Now that's the first thing. Okay, if the question gave you they actually told you that how much is the magnifications of MO and then how much is ME, then your life are simple, right? If not, right, then we go for second options. Now, as I say, microscope, you will have image form. There will be image form. Okay, your first lens will form first image, and then you draw again to form the second image. So anyhow, there will be two image form. Now you don't worry, the drawing wise, you can refer to my next video, then you understand what I'm saying now. Okay, so here's the thing: how do you calculate this? You need to recall a bit on one thing. Do you remember how we normally calculate magnifications? The usual one. Let's say you only have one lens. How do you calculate magnifications? It will be V over U, right? The distance of image. Or now, beside this, right? What else? You can also do HI over HO. The idea is what? Is about image divided by object. Magnification is simply just the ratio of your image and object. Okay, so you can do height of image over object, or you can do distance of image over object. Okay, but here's the thing: when you have MO and ME, right, you need to understand which one is your image, which one is your object. Now I simply draw one now. Okay, roughly sketch one. Imagine this is a microscope. So there will be an objective lens here, and then there will be an eyepiece lens here. So what happened is that you will put your object here. This is your original object. The object will go through the first lens, which is your objective lens. Okay, you draw, and then they will form an image here. Now this one is the I1, the image that is produced by your objective lens. Then, right, you base on your I1, you draw again to kind of form your I2. Doesn't matter where, roughly sketching only, okay? So what happened is something like that. Now I use different colors so you can see clearly. What happened is for objective lens, this is your object, and then it produces I1. And then after that, for eyepiece, right, you take the I1 as your object, and then they will form the second, which is your final image, I2. So there's 3% here. You got object, you got I1, you got I2. Okay, when we go through drawing, you understand what I say. Okay, you can try drawing yourself anyway. All right, so here's the thing. If you're trying to calculate magnification of objective lens, as in this guy, to calculate magnification, what you do? You take height of image over object, right? Then you start thinking, which one is the image of your objective lens? Which one is the image of objective? I1. Okay, then this is the object you draw. You draw this one, and then you form your I1, all right? So that's why over here, I will do HI1 over HO. Okay, image over object. But now you think about this. If I drawing eyepiece, which one is the object? Do I use the object to draw or not? You don't, am I right? What are you using? You are using the I1 to draw, and then you form an I2 here right now. So magically, this thing become your object, and this become your image. You getting what I mean? So it's different perspective. So that's why, right, for eyepiece, right, what happened now is it's gonna be height of image over object. My image is I2 divided by height of I1, because now I take I1 as my object to draw I2. So this is object, this is image, this is image, this is object, this is image, this is object. Just that we are looking at different lengths. And then of course you can see there's this I1 here, there's I1 here. Cross multiplication, you can cancel off them. And then finally, you are taking H of I2 divided by H of object. You can get the magnification of microscope. Okay, and you think about it, it makes sense, right or not? Ultimately, no matter what we do, we calculate using image over object. So if you look at the microscope as whole thing, which one is the object? The original one, the beginning one, the origin, which is this one, right? The origin starting here. And which one is your image? Actually, what did you saw? Did you saw I1 or not? You don't. You look into the eyepiece, you actually see I2, isn't it? So isn't this my real object, and isn't this my final image? And exactly, image over object. Exactly. So that's why, right, over here, so over here, right, what happened is, now again, I repeat, we are focusing on calculations. We are focusing on calculation and also the features. So if you want to learn more about drawing, right, you can refer to the next video. Yeah, so if you are let's say confused about why the image 2 is there, why the image 1 is there, you go through the next video I have for drawing, then it will be much more clear. So this is 2 parts. You must learn together. Yes, you can't just look at one part and then you probably be like a bit stuck and confused one. It's normal. but you look for both video, you watch the drawing one as well, then it will be better for this thing. Okay. So I also talk about the magnification already. Okay. And that's it. This is all the feature I need to know. All right. Now 3 main points. Let me summarize everything again. One shot so that you can see what is the difference, what is the similarities between them. Okay. Now, so today we talk about microscope and telescope, 2 of them, right? So first thing first, they are both considered as the compound lenses, which is what? 2 pieces of convex lens. 2 pieces of convex lens combined together. That's why I call compound lenses. All right. Now, then the next thing is, let me take this away. Let me show you the comparisons. Number 1, if you talk about the power, okay, power of the lens, right? Now for telescope, power of eyepiece will be larger than objective. Okay, power of eyepiece has to be larger than objective, means when you choose that time, you be careful. And then for microscope, it will be PO larger than PE. Now, if you kind of stuck here, I teach you one simple trick. Very easy. You know, how can I tell straight away without having mistake, without confusing them, right? Actually, very simple. And look at the words. The name of them told you already. Now you look at the word telescope. What you do, very simple. You go and count the letter. How many alphabet E I have in telescope? 1, 2, 3. Then you go and count the letter O. How many letter O I have? 1. So of course, E more than O, right? Done. And now that's the thing. Of course, this is only coincidence, but in exam, please don't write that as your explanations. Why do you choose PE as your PE bigger than PO? Because there's more E inside telescope. That is not explanation, all right? It's just a small trick for you to learn. Now, microscope, you count. It works for both. That's why it's good, all right? You see, 1, 2. How many letter E we have? 1. So of course, PO more than PE, right? Simple trick like that. So next time you don't have to confuse anymore. You go and count the letter E and O. Everything settled for you. Okay. Now next one, the distance of the lens. For telescope, right, it will equals to your FO plus FE. So you have to sum them up together and get your distance, the lens. So if your focal length is 2, and then the other one is 8, the distance between them has to be 10, because sum together, right? Now for microscope, it will be more than FO plus FE. So what happened now is, if let's say your FO is 2, your FE is 8, you sum them up, it's actually 10. Your distance of the lens has to be more than 10. You can adjust like 11 cm or 12 cm. Don't need to be too far away. Normally, we will just slightly increase, slightly more than like about 1 or 2 cm. That is enough. Okay. And then lastly, this one is, how do we calculate magnifications? For telescope, right? FO over FE. Okay. And then for microscope, it will be the image of the height of, the height of image 2 divided by height of object. Or you can do MO multiply ME if that is provided here. If they actually gave you the value for objective lens magnifications and the eyepiece magnifications. Okay. Now there's one more trick for this as well. Sometimes you say, hey, what if I terbalik this? What if, like, I mix them up, I put like FE on top. Now, one more trick for you is what? For telescope magnifications, right? Your value is always more than 1. The magnification for telescope is always more than 1, larger than 1. And you think about your maths theory. You want a number that is more than 1, what must you do? The value on top must be larger than the value at the bottom. The value on top always be larger than the value at the bottom. So let's just say you really forget in exam. You got 2 value, you got 2 focal length, you don't know which one is which. All right, take the bigger one, divide by the smaller one, then your answer will be the magnification of telescope. Okay, now this is the feature of telescope and microscope. And if you want to learn the drawing as well, then you go for the next video. All right, and I hope you learned something today. See you again. Bye-bye.